And welcome back, ladies and gentlemen. We are now going to get into talk about references and class parameters. Particularly, let's talk about variables and memory. So getting started, variables of a class type and variables of primitive type behave quite differently in Java. We've seen this. For example, when we talk about like the integer versus an int primitive type. Variables of primitive type name their variables in a relatively straightforward way. For example, if n is an int, then n can contain a value of type int, such as 42. If v is a variable of a class type, then v does not directly contain an object of its class. Instead, v names an object by containing the memory address of where the object is located in memory. So talk about memory, let's talk about secondary and main memory. Because a computer has two forms of memory called secondary and main memory. The secondary memory is used to hold files for more or less permanent storage. So think about things like your hard drive. The main memory is used by the computer when it is running a program. This would be things such as your RAM. Values stored in a computer's variables are kept in this main memory. That's why, if the computer shuts down, you lose all that stuff that's in there. It will help our understanding of class type variables learn a few details about how program variables are represented then in main memory. For now, assume each variable in a program is some type of primitive type such as int, double, or char. All right, byte addressing. Main memory consists of a long list of number locations called bytes, each containing 8 bits, that is, 8, 0, or 1 digits. Remember, we learned a little bit about this in the beginning here, so it's a nice good refresher to see some of this information again. The number that identifies a byte is called its address. A data item, such as a number or letter, can be stored in one of these bytes, and the address of the byte is then used to find the data item when it is needed. Memory location. Most data types have values that require more than 1 byte of storage. When a data type requires more than 1 byte of storage, several adjacent bytes are used to hold the data item. In this case, the entire chunk of memory that holds the data item is still called a memory location. The address of the first of the bytes that will make this memory location is used as the address for the larger memory location. Thus, as a practical matter, you can kind of think of the computer's main memory as a long list of memory address locations of varying sizes. So, variables of primitive type. The size of each of these locations is expressed in bytes, and the address of the first byte is used as the address or name of that memory location. Each primitive type variable in a program is assigned one of these memory locations, and the value of the variable is stored then in the memory location. All right, quick segue of asking why 8 bits. A byte is a memory location that can hold 8 bits. Why so special by 8 though? Why not we use 10? Because after all, we use 10 in most of our other operations. Well, there are two reasons why 8 is very special. The first is 8 is the power of 2. 8 is the same as 2 to the third. Since computers use bits, which only have 2 possible values, 0 and 1, powers of 2 are more convenient than powers of 10. Second, it turns out that 7 bits are required to code a single character of the ASCII character set. So 8 bits, or 1 byte, is the smallest power of 2 that will hold a single character. All right, here's our last little bit for today of variables in memory. So in here, I just have a quick example of a memory. So in here, we have bytes 1, 2, and 0. So this holds variable 1. It's a 3-byte variable, and it starts at address 0. Then we have a 2-byte variable. It's at address 3. We have variable 3, which is a 1-byte variable. It's at address 5. And lastly, we have variable 4, which is a 3-byte at address 6. So this is a quick illustration to kind of show you how different variables get divided up into memory. And that's going to conclude our notes for now, folks. Until next time.